When we are graphing a parabola in the form of y equals ax squared, we are basically just going to slightly more accurately graph this parabola because there aren't any changes to x or changes to y, just this little change to a. So in general, fractions make fat parabolas and whole numbers greater than 1 make skinny parabolas. Negative numbers make flipped over parabolas like this. So this graph is going to make a fat parabola, and we're going to need to have some points to put on our graph. So you're just going to have to come up with some. We know that the vertex is going to be at 0 and 0 because there are no changes, no x minus something in parentheses, and then there's no plus something on the end. So we know that we're going to have 0. You could check that by plugging in 0. If I plug in 0, I will have 1/3 times 0 squared. 0 squared is 0, and 0 times 1/3 is 0. So we definitely have that 0 and 0 point. Then you could come up with some other points, like maybe plug in, I'm looking for something that's going to be a little easier with that 1/3, but you can certainly use probably a calculator if you need to. Let's see, 3 squared would look like this. 1/3 times 3 squared, or 1/3 times 9 over 1. And so I can cancel. 3 goes into 3 one time, and 3 goes into 9 3 times. So that actually leaves 1 times 3 on the top, 1 times 1 on the bottom is just 3. So if I plug in a 3, I will get 3. Let's see, what else? When you plot that, you're going to go 1, 2, 3, 1, 2, 3, and put a point here. You're going to have a matching point as if it's across a mirror over here. So it'll be like 1, 2, 3, 1, 2, 3. So you don't have to put that in there. If you need to see that, what's happening is we're putting in a -3 for x, and the negative would be in the parentheses there. So -3 times -3 is 9. You're going to get the same number again. So maybe you could try negative things that might come out nice. Let's try maybe 6. So if I do that, this may get too big, but let's just see really quick. 6 squared. See, I'm just plugging it in for x. And so I have 1/3 times 36 this time. 3 goes into 36 12 times, and so my answer is going to be 12 that goes with 6. So as long as your graph is big enough, you can go over 1, 2, 3, 4, 5, 6 and up 12, and put that point there, and then the matching point on the other side is going to go -6 and 12, and then you hit the little thing that connects your dots. I have not drawn this in any way that makes sense at random here, but when you put it into the Alex equation, or I don't know, I was thinking about something else, sorry. When you put it into the graph in Alex, it looks like this, and the answer, they've done a table. Look, they picked the same values that I did, and then they came up with the points. You put the points on the graph, and you hit the little part that says connect the dots, and you get it. So the quicker answer is you need to make a table of values like this, where you pick some values for x, and you plug them in to the equation and solve it and get the values for y that go with those x's.